It's rounding to a given significant digit. The key with this is always in the zeros. We're all quite happy that an integer number, if it's shown, is going to be a significant digit when we take a lab measurement or whatever. What confuses people is leading zeros, captive zeros, and trailing zeros, okay? So if we have a leading zero, that means a zero on the front of the number. It's not significant, okay? The way you can always be sure is if you use standard scientific notation. So scientific notation is where you have a number between 1 and less than 10. So it can be greater than or equal to 1, but it has to be less than 10, and you express that with an exponent, so times 10 to the power of either a positive number or a negative number, depending on the order of magnitude. So if your initial digit is m, it'd be m times 10 to the power of, let's just say n for another number, and I'm going to try and write that really small, so you can definitely see that as an exponent, okay? So the rule for this letter m then is m has to be bigger than 1, okay, or equal to 1, so greater than or equal to 1, and it has to be less than 10. I could draw the less than 10, okay, probably, because if it was 10 or above, then you'd increase the power by 1, okay? So we want a less than or equal to, because it could be exactly 1. So I'm going to try to draw another line here. So that is the rule for writing something in standard scientific notation, okay? So for example, with leading zeros, if the example was, let's see, 0.000335. I don't know how many significant figures it is. So what I'm going to do is I'm going to write it in standard scientific notation. So you would drop that first zero, wouldn't you? You would say 3.35 times 10 to the power of, count the zeros, 1, 2, 3, minus 4 would give me that right number. So look what I've done. I've got rid of all those leading zeros. So then it must be 3 significant figures, okay? Captive zeros are usually fairly easy to spot. So those are ones that are in between other non-zero integers, and those are significant. Significant. Sorry, sometimes my brain goes faster than my fingers. So for example, if I said 808, I bet it's Tube Screamer. If you were going to say how many significant figures it is, you'd be like, yeah, sure, that is going to be 3 significant figures, right? Sometimes writing it standard notation might help you, right? 8.08, you'd write times 10 to the power of 2, right? So again, you would keep that 0 in, right? The one that always confuses people is the trailing 0. So by that, I mean zeros that come after other integers. They're on the end, right? So the trouble with this is it depends if there's a decimal point, okay? So case 1, no decimal point, no decimal point. Then they are not significant. Ah, okay. So if you're not sure, let's do an example, okay? So say you had, I don't know, 1800. Well, let's write it in standard scientific notation. You just write 1.8 times 10 to the power of 1, 2, 3, right? So what did I do? I got rid of those zeros, right? So if you were writing 1800, and you wanted to be, those zeros are significant, what you'd have to do is you'd have to use a decimal point, okay? So with decimal point is showing that they are significant. So if I was to rewrite that, significant. So if I then said 1800 point, okay, I'm now saying that is 4 sig figs, right? I should have written 2 here. So let's write it. I would write 1.8, and I would keep those 0 zeros because of that decimal point, times 10 to the power of 3, and now I'll be like, well, 1, 2, 3, 4, that is 4 sig figs, okay? So scientific notation will always help you out here. So in this case, we're asked for how many to to round this to 3 significant digits. So first of all, what we're going to do is we say, well, these aren't significant, okay? So 3 significant digits will be 1, 2, 3, right here, okay? So then we have to worry about rounding. The rule is to know if you have to round or not, you have to look at the digit after the last significant digit, okay? If it is under 5, then you just chop it off and off you go. If it's 5 or above, you round up. Now 7 is 5 or above, so we're going to round up. So that is going to be to 3 significant digits, 11.6 grams. Okay, so let's look at a few more. Okay, 0.0, no, where is the point? Here's the point. We are asked for 4 significant digits, and this is an interesting one actually, because 4 significant digits, well, we would be getting rid of these ones, and then 1, 2, 3 significant digits. We do not have a 4th in our measurement. You should not add one here. Okay, so we can give it to 3 significant figures. It'd be 23.2 to 3 significant figures, but we cannot round it to 4 significant figures. This measurement is not precise enough for the chemist. Okay, I'm not sure exactly how you tell ALEKS that, but I think you just, whatever. I don't know because I don't see that. All right, so let's have a look at one more then to make sure we've got all the possibilities. Okay, we're asked for this to 2 significant digits. Oh, this is a great one. So again, the leading zeros we're going to get rid of. 2 significant digits would be here. Oh my goodness, all the 9s. We've got to be so careful here, okay? Because this is above 5, so we're going to round up. So that's going to round up. Oh, it's a 9. It's going to round up to 100, okay? So how do we write 100 with only 2 significant digits? Write it in standard scientific notation. 1.0 times 10 to the power of 2. Okay, be careful because this 100 is only 1 significant figure. If I wrote 100 point, that would be 3 significant figures. So this is why scientific notation will help you out here. Okay, so you're only asked for 2 significant digits. All right, we even had a trick question. Have fun with that.